This is TechSNAP, episode 404, for May 25th, 2019. Hello, and welcome to TechSNAP, Jupiter Broadcasting Systems, Network, and Administration podcast. My name is Wes, and of course, I'm joined by Jim.
What's up, everybody?
Now, Jim, seeing as this is episode 404, or maybe I should say 404, I think we both agreed we should do something related to HTTP. And why not start with that venerable component of the web stack, the HTTP server itself?
Yeah, I mean, it would be a huge missed opportunity if we didn't do something about the web with 404. And, there are a lot of misunderstandings floating around out there about Apache versus NGiNX, maybe even, light HTTPD, all that kind of stuff. So I thought we'd take a look.
Yeah, you'll find all kinds of guide for setting up, installing, configuring, and even just recommendations for web servers. But many of those are providing dated or maybe just misleading advice. And I thought, you configure this sort of thing every darn day. Maybe you can set us right. Do I really need to use NGiNX? Is Apache more capable? Where do I start in 2019?
So Wes, one of the things that's always bugged me is, there's all this uninformed commentary out there that if you're not using NGiNX, then obviously you're screwing up, that, nobody should be using Apache anymore. And things just aren't that simple. NGiNX is a great HTTP server, so is Apache. And in the right circumstances, there's even one or two others that might be worth looking at. Way back in the day, tiny HTTPD was really underrated for some tasks. That one's gone unmaintained for a very long time now, and nobody should probably be using it, but light HTTPD is still a pretty big deal.
Unfortunately, I know exactly what you mean. I think many people have an outdated view of Apache from the bad old days when things were slow. And also, they might not just be configuring things right. You kind of got to know what to do, and a lot of articles still have outdated advice.
They all have outdated advice. I mean, honestly, I haven't found a good setup article for modern Apache ever. And I've searched pretty hard. A couple or 3 years ago, I got in a conversation with Jim Jagelski of the Apache Foundation. So when I got in a conversation with Jim, I said, everybody always says NGiNX is so much faster than Apache, but it always looks like they're testing Apache, configured like way back in the old, 2.0 or, even like 1.6 days. Back when everything was Prefork. But, for a long time now, Apache has had different MPMs, multi-process modules, which basically just means how it handles incoming connections. Prefork is the original one, and if you want to use a language like PHP with Prefork, the big problem there is that you're loading up an instance of the entire language in every single child process. So when we talk about the way that Apache used to work and whether or not it's fair to compare current Apache versus NGiNX using these ancient configurations, we have to look at some of the differences that have come about. And the biggest one is something called an MPM, a multi-process module, which is a not very human-friendly way of saying how Apache handles incoming HTTP connections. The original Apache, all the way up through, I think, 1.4, maybe 1.6, it used a prefork style. And what that means is that you would fork an entire new Apache process for every single incoming connection. And that wasn't so bad when you were only handling static data. How the web started out. You just had HTML files and, JPEGs and whatever. But once you started getting into things that took a lot of time to process, in particular, once PHP became, kind of the king back-end language of the internet, now you're having to load an instance of the entire PHP language with every single forked Apache process to handle every single incoming connection. Now that changed in the, later, I want to say it was either 1.6 or 1.8, Apache introduced the worker NPM, which absolutely nobody used because, they weren't familiar with it and you had to change how you did things and it was scary. But what worker and then later the event NPMs do is rather than forking off the entire server, they actually just handle new incoming connections in threads. And that can have a really big impact on the amount of memory usage. And the memory usage of your HTTP server and its child processes, that's really key to how many incoming connections you can handle on a web server. The bigger and the fatter a chunk of RAM you have to allocate for handling every incoming connection, the fewer of those connections you can handle at all. And that becomes a really big deal when you get out of the world of, nice, clean benchmarking on the same network with your web server where everything goes super fast. And you talk about, now I have to service real world HTTP requests that are coming from people on, back in the day it was dial-up, but now it's, people on terrible Wi-Fi or, really dodgy cell phone connections while they're riding the subway, whatever. It tar pits you really bad. So
right, because if you have a long-lived connection in the old model, that's a process hanging around that entire time as you wait for them to send back the responses.
Exactly. So if you've got this super fat child process that eats up a ton of RAM, normally it would be able to finish what it's doing pretty quickly, but now it can't. It has to hang around because you've got this tar-pitted client hanging on to it for, maybe full seconds, a request that should have, completed in 30 milliseconds. That's a real problem. So where Worker and the event NPMs come in is they allow you to have much, much lighter weight processes handling each of those incoming requests. You have a few full forks of the entire Apache server, and each one of those can handle by default up to 50 threads. And every one of those threads handles an incoming connection. Then above and beyond that, where it gets a little bit more complicated is, where with the old school Apache, the PHP language was just loaded directly into the Apache process and everything happened inside that one big fat process.
You're talking about mod PHP?
Exactly, mod PHP. If you're using mod PHP, you are using the old Prefork NPM. Even if you thought you were using a different one, the second you install that module, it automatically shifts you back to Prefork.
Oh.
But when you're on Worker or Event, or you're using NGiNX, you're not going to be using mod PHP at all. You're going to be using some type of a fast CGI process, and usually that's going to be something called FPM. Now, with FPM, your PHP processes are actually entirely separate from your HTTP server processes, and you can have different counts of them. You might be able to say, okay, well, I want to be able to handle, 50 incoming HTTP requests, but I only want to have maybe 5 PHP processes running because I know those are going to eat a lot more memory, and I can't afford to have as many of them. So you shouldn't be using mod PHP. You should be using FPM. FPM is a new type of fast CGI module. And what that allows you to do is have a separate number of PHP processes that are accessed by your Apache or NGiNX processes. So even though Apache or NGiNX may be servicing 50, 100, 500 incoming requests, they'll only be able to tie each one of those incoming requests to as many PHP processes as you set up in your FPM pool. Now, I did some testing for this show. I spun up several droplets on DigitalOcean. They're absolute cheapest, $5 a month droplets with 1 gig of RAM. And I configured Apache with the Prefork NPM and the event NPM, which is the newest one, and I configured NGiNX. And Apache Event and NGiNX are both using PHP FPM, like I described with the pool of PHP connections. And Prefork, of course, is doing the old school mod PHP.
All right, you've got things set up, a legacy configuration, and what should be modern best practices. What did the results show?
The results were actually pretty frustrating. It's very difficult to get results that jibe up, with the actual experience that I have as a system administrator for, very large scale websites. What I know from, many, many years of experience managing these websites is that the amount of RAM required to handle each incoming connection is absolutely crucial for scale, because the biggest thing that you need to scale your website to handle lots and lots of incoming requests is, again, because so many of them are going to be, super slow or they're going to hang on forever. You need incredibly lightweight processes to just talk HTTP to these people and then let all the big fat stuff happen on the inside, as rapidly as humanly possible.
Right, you need the HTTP stuff because you're going to have so many concurrent connections. You need that to be as simple as possible.
It's very difficult to empirically demonstrate that with, real numbers without an actual huge number of really crappy clients. When you're testing everything from the same network or even from, a decent unsaturated network at some distance, what you end up doing is you end up selecting for just which web server actually handles the connections the fastest. But in real life, handling connections faster is great. And that's one thing that, NGiNX is very good at. Surprisingly, the old school Apache Prefork is actually the absolute best at that.
Really?
Yeah, if you want to accept your incoming connection and serve up the web page and slam that connection closed as fast as humanly possible, Prefork handily beat the pants off of NGiNX and the newer NPMs for Apache both. The problem is that you can only have a very few amount of these, Prefork processes hanging around to answer these incoming requests. When I configured Apache 2 event model on this 1 gig droplet, I configured it to handle 50 incoming HTTP requests, and I had 50 PHP workers in the FPM pool. And I did the same thing with NGiNX, and for the most part, they were stable. Now, the Apache 2 event, it absolutely never, ever had a problem set up that way. NGiNX mostly didn't have problems, but 2 or 3 times it would actually end up running the droplet out of RAM, and the OOM killer would kill off my MySQL database.
Just what you want to have happen.
Yeah, you don't want to have that happen. So, in real life, I really should be tuning the NGiNX down a little bit further than that. The Apache 2 was fine with 50 and 50. NGiNX, not quite so much. It's also worth noting that, the only thing I was actually testing on these droplets was, a default WordPress install with the default theme and only one post on it. If you're doing a lot of modern web applications, including WordPress with themes and extensions and plugins and, bigger, heavier posts than what I'm doing, you may end up using a lot more RAM per PHP process than I was there. But with that said, it's really hard to get a direct handle on how much RAM you're really using per process because, if you're just limited to using RSS and VSZ, from top on the command line, you don't really get a very good handle on how much of that memory that's used is shared libraries that multiple threads are using versus, stuff that is only with one or the other. So it's hard to say, concretely, okay, this is exactly how many megabytes per child I'm using. But when you see the OOM killer, killing off your MySQL database, you've definitely tuned it too high.
All right, so some firm figures, that's proving difficult, but what did you see in a subjective sense?
So in a subjective sense, it was fairly obvious that Apache 2's memory usage was a little lighter weight than NGiNX's, which was kind of a surprise. But, I ran hundreds of thousands of web page fetches against each one of these server setups, and the tuned identically, the Apache 2 never, ever killed anything off for lack of RAM, and the NGiNX did 2 or 3 times. The really big difference, though, wasn't between Apache 2, with the event handler and NGiNX. It was versus either of them and the old Apache 2 Prefork. And this shouldn't be a surprise when you understand how Prefork works, but when I set Apache 2 Prefork up to handle 50 incoming connections, it would just instantly kill off the MySQL database every single time I tried to hit it from Apache Bench, without fail. So I had to tune it way, way down. It was stable at 20 incoming requests, but any more than that, and you're going to lose the database.
Right. That's a great example of why this really matters, right? Because you've just had to fundamentally limit the amount of users you can handle at the same time.
But again, that's really difficult to just directly demonstrate because the frustrating thing is that when you're just looking at, how many requests per second did you actually service from another droplet, in the same DigitalOcean data center, that old school Apache 2 Prefork, even though it's only handling 20 concurrent connections, it was turning them over so rapidly, it was actually fulfilling more requests per second than either NGiNX or the more modern Apache 2. The problem, again, is that, in the real world, you don't have super duper fast clients, on the same gigabit LAN with, almost no latency, downloading things as fast as you can. You got some dude on his phone on the subway.
Right. It's important to actually understand the types of connections and users you have. Otherwise, your benchmarking is maybe not so useful. You've got your server tuned, you've selected an HTTP server, you've done some configuration, you've measured, and you've definitely not used Prefork. How do you scale beyond that in a sane way?
Well, the way that most people scale beyond that is setting up a CDN, a content distribution network. The upside to a CDN is that, you pay your little subscription fee and for a relatively small amount of money, now you're no longer serving your static files, your CSS and your images, things like that don't change. You're not serving those directly from your own web server. Those will get transparently proxied in from a content distribution network. The CDNs typically have, a nationwide or worldwide reach. Their servers are going to be closer to your clients than your web server is, and they're going to handle all the load. It's going to make everything scale much, much, much faster, because now instead of, somebody loads up your the index page of your blog and, needs to load anywhere between 20 and several hundred separate resources from your server, now they're only going to be loading the actual page from your server, and all the other stuff is going to get delivered by the CDN itself.
Right, pushing off all the stuff that's not unique to your web server to someone who's already got that covered and is going to be faster anyway.
Well, it's unique to your web server. What's not unique to is that individual HTTP request.
Right.
If you hit a WordPress page, for example, there's going to be some dynamic elements that are, they may very well be individual to each particular person who's actually looking at the page. But things like the theme, the CSS for the theme and the images that are displayed in the post, all these things are static. They're not different per user, and they can be pushed off to the CDN. Now, the downside with the CDN is, we kind of brush it off at the start, but it costs money. To get the use of somebody's content distribution network, you need to pay them. And it's typically going to be, an amount that you pay in gigabytes of actual transfer per month. And, for most sites, it's not a whole lot of money. The thing that has always scared me about CDNs with anything personal is, if you get slash dotted, then all of a sudden what's usually your $5 a month CDN bill might turn into a $1,000 bill.
Right. The upside is everything keeps working. The downside, you're on the hook to pay for it.
Exactly. I think, these days most people are just going the straight CDN route. But, back in the day before CDNs were everywhere and before they were quite as inexpensive as they were, I would also see a lot of, more complex setups for really large, really high performance websites. We're talking stuff that's like in the Alexa top 500. When you're setting up a site like that, you're not just going to have, one single server, whether it's Apache or NGiNX, that serves all the content. At this point, it's almost like you're setting up your own content distribution network, although it's not geographically dispersed. You'll have one server that's optimized for, doing the actual dynamic stuff. The PHP or Ruby or, whatever your backend language is, this is going to be an application server that's optimized for chewing through that stuff as fast as it can and delivering the dynamic content. Then you're also going to have a static server that its whole job is nothing but serving static content as fast as humanly possible. And that server is usually going to have a different engine. It's going to be configured a lot differently than your application server. In front of that, you're probably going to have one or more proxy servers running something like, say, Varnish, that is absolutely optimized for keeping as many connections open as possible. And it doesn't really have to do any thinking at all. It just reverse proxies those down to the inside of the network. Now, that might seem kind of useless, when you first think about it. Like, what good does it do me to have a machine running a reverse proxy when it's just connecting to a machine right behind it and connecting its results right back out again?
Right. Haven't I just added an extra layer there and maybe some delay?
Right. So you've maybe added a little bit of delay there, but what you've really done is now you have this specialized server that one server may now be able to literally open, hold 5,000 or 10,000 connections open out to the great unwashed masses with their terrible internet connection that may be tar pitting you for, seconds, tens of seconds, sometimes maybe even minutes at a time. You've got this really, really cheap connection to them that all it does is just trickle data down to them at whatever rate they can accept it. Now, on the inside, when that server makes the connection to the servers that really do the work, your application server and your static server and all those, it's local, it's right there on the network, it's got the absolute fastest, lowest latency possible connection, so it can make and break those connections lightning fast, no matter how slow the client making the request to the reverse proxy is. I had a client with a very large online retail site that, 10 or so years ago, they were using Magento, and I cannot overstate how large the reach was on that site. And when they first brought me on board, it was not at all uncommon for a page load to take 8 or 10 seconds when you got deep in some sections of the store.
Yikes.
And the very first thing that I did is I put Magento in front of that thing as a reverse proxy, And even before I got the caching working right, when, Varnish was doing literally nothing but handling the results, getting the data from the application server and then trickling it back out to, the actual clients, whatever rate they could accept, that immediately brought typical page load times down from like 8 seconds to, like 150 or 250 milliseconds. That's the kind of impact it makes having a proxy out in front so that your application server doesn't get burdened down by these slow clients.
That sounds like a huge win. And you hinted at maybe another one. If you have one of these proxies in front, it can also function as an additional layer of caching, right?
Yeah, exactly. So, we're kind of going back to that whole concept of be your own CDN. And, again, falling back to this client that had the really, really large Magento, online shopping cart type site. Even without the caching, Varnish was a huge win. Getting the caching working is really surprisingly difficult on Magento particularly. It doesn't do a very good job of differentiating what's dynamic content versus what's static content. So it took me about a week to finally get all the definitions right so that I could safely turn, caching on with Varnish. And that just made the site even that much quicker, because what happens then is, just like with a CDN, you're not actually hitting the backend server for images and CSS files and things like that. In that case, Varnish, just like the CDN would, Varnish will read that image or that CSS file or that JavaScript file or whatever once and then just save it locally. And then it doesn't even have to bother the backend server at all when it feeds those files to clients.
Okay, well, honestly, that sounds a little too good to be true. What sort of limitations or downsides are there by adding something like Varnish to my stack?
That's a different answer whether you're asking something like Varnish or you're asking about Varnish itself. Back in the day, Varnish was just hands down the best caching or non-caching reverse proxy out there. These days, unfortunately, it's pretty much irrelevant. Despite having a really rich language that allows you to get the most out of the caching capabilities and being able to handle insane amounts of ongoing connections at once effortlessly, Varnish is pretty much useless these days because it doesn't handle SSL. So in order to use Varnish now, you'd have to have something else as an SSL terminator, reverse proxying to Varnish, which would then maybe be able to reverse proxy to your actual applications, and that's just not a win. In place of Varnish these days, you might actually use Apache or NGiNX or Light HTTPD themselves configured as a reverse proxy with absolutely nothing else loaded, nothing going on. So they got the most minimal possible memory footprint, and they might act as your reverse proxy that then reaches into a differently configured NGiNX or Apache on the inside that has all the heavy stuff going on.
Are there any plans to add SSL or any other tools you might recommend to fulfill the role that Varnish once played?
Honestly, no. I heard people talk about Pound as an SSL terminator back in the day. I experimented with it. I never really got anything good out of it. There may be something that I just wasn't seeing, but it's not anything I can personally recommend. The last time I needed to set up a reverse proxy, and I did need to support SSL termination, I ended up just using, I believe, Apache itself. I might have used NGiNX. Either one can make, a perfectly fine reverse proxy and actually support the SSL.
Do you have any tips for how you might choose between them? I mean, they're obviously both awesome, capable web servers. Do you find yourself reaching for one or the other in certain scenarios?
Well, as long as you're using modern configurations and you understand what you're doing, they're both very capable tools, Apache and NGiNX. So a lot of it just kind of comes down to, what you're used to. If you're not used to either one, and you want to figure out, okay, which one do I really want to get my feet wet first, I would still honestly recommend Apache. I'm probably in the minority there. People have been saying, NGiNX is what the new kids use, for a long time now. But which is the absolute fastest web server honestly kind of goes back and forth. When I first started benchmarking them a couple of 3 years ago after that conversation with Jim Jagelski, they were pretty much a dead even heat. NGiNX was slightly faster than Apache for some things. Apache was slightly faster than NGiNX for others. And the memory usage profiles seem to be about the same. But when I tested this stuff again this weekend, what I discovered is that NGiNX does absolutely open and close connections faster than Apache does. But Apache had, it's not huge, but it had a measurably lower resource usage per connection. So Apache is actually probably going to make, in my opinion, the better reverse proxy. NGiNX can open and close those individual connections a little bit quicker, sure, but that's rarely what's truly slowing your web application down.
All right, well, that's all well and good. It's great to have a well-configured web server or reverse proxy, but you still need to put some attention in the application itself, right? I mean, at some point, if your app is slow, there's not so much a web server can do.
Yeah, absolutely. I wanted to benchmark WordPress for this because, it's a pretty good middle of the road, like tons and tons of people are using it, and it's a fairly good facsimile for a lot of web applications out there. Nice heavy use of PHP, so you're really stressing the kind of systems that you would in the real world. So I find it to be a great target for benchmarking. But with that said, you have an interesting choice once you start benchmarking these things. Do I benchmark it, literally just install WordPress and go, or do I go ahead and configure a caching plugin first? Generally, in this case, I wanted to benchmark Apache versus NGiNX, and so I really needed to go ahead and install a caching plugin for WordPress. I use W3 Total Cache, and when you install that plus the PHP APCU package, APCU is a PHP opcode cache, and W3 Total Cache allows WordPress to cache full pages and also database queries and even objects, which basically are database queries wrapped in the HTML elements that make them pretty on the page. You can store all these things locally in the PHP APCU cache. If you don't do that, you can't really benchmark Apache or NGiNX because what you're benchmarking is the MySQL performance behind WordPress. Once you set up the caching, now you can actually see the impact that the individual web server has because you go from about 10 requests per second that are very much limited by what MySQL can do to, 300 or 400 requests per second. And now you're going to be bottlenecking at the actual web server where you want to be.
As always, benchmarks can be difficult, and there's no shortcut to actually understanding what's going on. Do you have any favorite benchmarking tools? What did you use when you were running tests this weekend?
It's very, very old school. It dates back to the 90s, but I'm still a big fan of Apache Bench. If you're an Ubuntu user like me, it's part of the Apache 2 utils package. And Apache Bench, AB for short, it's a pretty simple tool. You point it at an URL and you tell it, how long you want it to run or how many requests you want to make. And you tell it how much concurrency you want. And it does the thing. It tortures the web server until it's gone through all the requests you asked for with the concurrency level. So for my testing, I was running AB-C50-T30, which means I want you to fire up 50 parallel processes and download this URL as fast as you can for 30 seconds.
That sounds simple and easy. I like it.
Yeah, the big drawback is that what you're missing when you use Apache Bench is you're not downloading all the actual resources in the page. You're only downloading the page itself. So if you want to really simulate the impact that downloading the page and all the CSS files and any images and any JavaScript files and yada, 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 you're going to need something more complex. I actually did play around with that. I adapted my tool NetBurn to allow me to feed it an URL list and to fetch all of the resources on my little default WordPress page in parallel. And it worked. Honestly, in this case, it didn't really tell me anything that I didn't already know.
Oh, I see. What do you mean?
My big challenge was honestly that I wanted to make the old Apache 2 Prefork fall over harder than it appeared to be. It was just really griping me that it was, turning in faster, requests per second numbers when I knew for a fact from years and years of experience, if you set up Apache that way, the first time you get slashdotted, your site's going to fall over. And these results appeared to show you the exact opposite. Oh, well, Prefork can handle more requests per second than NGiNX or Event can. You just have to tune it down further and everything will be fine. But everything's not fine because you end up getting tar pitted by these clients making all these, very, very slow requests. And that was the thing that I couldn't simulate. When I modified NetBurn to allow me to fetch all the resources off the page, the Apache Prefork was still turning over all those individual requests quicker, where it would have really, fallen over had I had some way to simulate it. If I had been able to make NetBurn say, no, I want you to only accept this data at, 50 kilobits per child, then Apache would have really just absolutely, the old Prefork Apache, it would have just died because I would have tied up all 20 child processes it had available, and they would have, sat there forever while the NGiNX and the Apache event model was turning them over much more rapidly because, it could just keep accepting, connections on new threads for all these static files, which greatly outweighed, the one dynamic file that couldn't just be served statically. So it would be able to turn over these requests a lot quicker. But without that actual tar-pitted connection that takes forever to service these requests, you're not really able to see that happen. Now, there is one thing I wanted to mention, as long as we're talking about using Apache the modern way with the event or the worker model, there's a very critical step to that I have not seen correct in any guide I've looked up at any point on the internet. I moved all my own servers over from mod PHP with Varnish in front of it to a more modern Apache using the event model a couple of years ago. Was it even a couple of years ago? Relatively recently, so that I could finally, have my sites using SSL certificates like a grown-up. And part of that process was, I knew I didn't want to still be doing Apache Prefork because I know it doesn't scale well. I wanted to use the event model. And I looked up guides, and they're just all over the place. They tell you to make all these crazy modifications inside all your vhost files, or they tell you to install a whole bunch of extra packages like fast CGI or this, that, or the other. Most of them just plain didn't work at all. And they all missed, there's one really simple, easy, crucial step that none of them mentioned. When you want to set up Apache with the event model or the worker model and PHP FPM, the only thing that you need to do to Apache itself is you need to enable the FCGI module. And on Ubuntu, that's already available with a basic Apache install. It's in etc. Apache 2 mods available. All you have to do is a2nmod proxy_fcgi.load. That's it. Once you do that, Apache is ready to proxy back down to your PHP FPM, and you're good to go. Now, what you absolutely don't want to do is what a lot of other guides will tell you, which is at some point they say apt install libapache2 mod PHP. Or, if you're not an Ubuntu person, some other version of install mod PHP. Do not do that. You will end up with the old Prefork model if you do, and your site won't scale.
Well, there you have it. Some tips from the field and some things definitely not to do. Thank you, Jim.
And folks, if you're new to all this and you've never set up your own WordPress before, it's pretty easy. I'm going to put up a quick guide to installing WordPress on a modern configuration of Apache on my website, jrs-s.net. We'll put a link to it in the show notes.
You can find those show notes at techsnap.systems/404. You can also find ways to get in touch at techsnap.systems/contact if you have some tips of your own favorite web servers or some horror stories about HTTP misconfigurations. That's going to bring us to the end of today's episode. Thank you all for joining us. If you'd like more of us before the next episode is out, we're both on Twitter. I'm at Wes Payne, and Jim, you're
at JRSSNet.
You can follow the whole network at Jupiter Signal. Thank you all for joining us.
See you in a couple weeks.